Okay. So, what do we have here on 5.5? Okay, so we're doing some operations on functions, okay? Meaning we're going to give you a couple of functions, and they're going to ask you to add them and subtract them. Sometimes they're going to ask you to multiply them and divide them, okay? We're going to start with adding and subtracting. So, on 5.5, the first question is question number 3, I think it is. Question 3, they ask you the same questions, okay? They're asking to add them and subtract them, and then they're also going to ask you to find the value of the function when you plug something in for it. So on this first function, they give us f of x and g of x. What is f of x and g of x? F of x is the negative 5 fourth root, negative 5 fourth root of x, and g of x is 19 fourth root of x. Fourth root of x, okay? And they ask you to do, they want you to do f plus g of x. And don't think hard on this. F plus g of x, I just kind of told you what we do. That's simply say, add them together. Add the two functions together. And they're like, man, this looks like a mess. It's not that bad. If you read it, what's negative 5 fourth root of x's plus 19 fourth root of x's? 14 fourth root of x's. Okay, I think probably the hardest part is going to be typing that in the computer, okay? Then they also ask us for f minus g of x. So instead of doing negative 5 plus 19, you're going to do negative 5 minus 19. Negative 5 minus 19 more is negative 24 fourth root of x's. Okay, and then what they ask you to do is they ask you to find f plus g of 16. Okay, they ask for f plus g of 16. So that's saying add them together. We already did that. And then plug in 16. Okay? Then later on, they ask us f minus g of 16. What is so special about 16? It's what they tell you to plug in. They're telling you on the computer. I always have students say, well, where does 16 come from? The computer says plug that value in. They want you to plug it in. Tell me what the answer is, okay? So we've already added them together. Plug in 16. So we have 14 fourth root of 16. Okay? And 14, remember, there's been some students that struggle with this. I want to make sure we understand this. 14 fourth root of 16 means 14 times the fourth root of 16, okay? And the fourth root of 16, be careful, it's not 4, okay? What is the fourth? I think you should know this one. Now, the fourth root of 16 is, what do we times by itself 4 times to make 16? 2. 2 times 2 times 2 times 2. Okay? So the answer is 14 times 2, which is 28. Okay, and they ask you to do the same thing. Plug in, is it 16 both times? I think it probably is. Yeah, they want you to plug in 16 for the same thing. So we've already subtracted them, so it's going to be negative 24 times the fourth root of 16. So it's negative 24 times 2, which is negative 48. Yes, ma'am?
So we're typing in 28 and 40, negative 40.
That's all yeah, what you're going to type in is this. I mean, I'm not interested in just getting the right answers. I want you to understand where they're at, and I know that you do want to figure that out. But what I'm saying is, they're going to say this is what you're going to type in here. You're going to type in this here. You're just going to type in 28 and 48, negative 48. That's all you're going to type in. You don't need to show all the work. I'm just showing it so you know where it came from.
Yeah, but so like we just type in, it'll have f plus g.
What I boxed in is what you would type in.
Okay.
This will be on the computer screen for you. You type this in, you type this in, you type this in, you type that in. And then, one more thing. They asked us for the domain, oh, that looks terrible, of f plus g. And what's the domain of f minus g? Domain. Okay? Yeah, there's only 10 questions, but there's several parts to each of them. But it's the same parts every single time. They ask us, what's the domain of this function? What can I plug in for x? What can I plug in for x? So what numbers can I take the fourth root of? Can I take the fourth root of any number or not? What numbers can I take the domain of? Negatives. So it's got to be numbers that are what?
Positive.
0 or positive. Okay, so x has to be bigger than or equal to 0. And then what's the domain of this one? Same thing. X has to be bigger than or equal to 0. You plug in anything that's not negative. Okay? And you're going to have to, again, they're going to ask what is domain. You're going to click and drag this, click and drag that. Okay? All right. Number 5. All righty. Can I erase part of this? Is it okay? Is everybody cool if I erase this part at least?
Yeah, you can erase it.
Okay. Just needs to take a little bit of space. Okay. Number 5. Put up here a little bit. So the functions they give us this time Okay, this one might be a little bit easier because it's stuff that you're a little more accustomed to. Some functions you're a little more accustomed to. There's no radicals in this one. So we have f of x is 6x minus 4x squared. 6x minus 4x squared. Then what? Minus 7x3. And then g of x is a function. Where are we? 9x squared minus 5x. 9x squared minus 5x. Minus 5x? Yep, okay. All right, so they want us to do f plus g, and add them of x. Add those two together. And I'm going to add them. I'm also going to put them in the right order, okay? So, which of these terms should I look at first?
X squared and negative 4.
I'd look at something else first. I'll put them in the right order, too.
X7.
Careful, not 7. Negative 7, x3. Why are we looking at that one first?
Because it's got the highest.
Highest power. What can I put with negative 7, x3? Nothing. Negative 7, x3. And then I'm going to put together my negative 4x squared and positive 9x squared, and negative 4 to positive 9 is a positive 5x squared. Then I'm going to look at 6x and negative 5x. That's a positive 1x. Okay? Then I'm going to find f minus g of x. Okay? So we're going to subtract those. Now, here's where we got to be careful, okay? I'm going to take these minus each of these. So what you need to understand is when I'm looking at these are going to stay the same. When I minus them, these things are going to be opposites, okay? It's this minus this. So the negative 7x3 minus nothing, so it stays negative 7x3. Then I'm going to take negative 4x squared minus 9x squared. Negative 4 minus 9 more is negative 13 x squared. And then I'm going to take 6x and minus 5x. 6 minus 5 is 6 plus 5, which is 11x. So we good with that? I didn't show my work. Are we okay with that? Okay, and then they ask us to plug in what this time? Negative 1. Negative 1. So they want us to plug in negative 1. Negative 1 for both of them. And again, where did negative 1 come from? They're telling you to. Last time they told us to plug in 16, I think it was. This time they're telling you to plug in negative 1. For all of the x's, for all of them, okay? I'm going to show my steps on this one. Negative 7 times negative 1 cubed plus 5 times negative 1 squared plus negative 1. Well, let's see. Do I times first or do powers first? Or does it matter?
Oh, I guess.
Got to do your powers first. You've got to do your powers first. If I do that, we have negative 7 times negative 1 cubed. Negative 1 times negative 1 times negative 1. What is that? Positive or negative? It's 3 negatives. Negative, and 1 times 1 times 1 is negative 1. Plus 5 times negative 1 squared. Negative 1 times negative 1 is positive 1. Plus negative 1. Negative 7 times negative 1 is 7. 5 times 1 is 5. Then minus 1. 7 plus 5 is 12. Minus 1 is 11. All we're doing is plugging in negative 1 for every single one of them. And then getting our answer. Now we're going to do the same thing here. We're going to cheat a little bit here though, okay? Here's what I'm going to do. When I plug in this negative 1, it's going to be the same thing when I plug it in here. So it's going to be negative 7 times negative 1 minus 13. When I plug in negative 1 here, it's going to be positive 1, just like we had here. Plus 11 times negative. Well, this one, 11 times negative 1 is going to be negative 11. I kind of skipped a step there. Are we okay with what I did? I'm just using what I did earlier. I knew that when I plugged in negative 1, it was going to be negative 1, so I put negative 1. I knew when I plug in negative 1 here, it's going to be positive 1 here, and then 11 times negative 1 is negative 11. Yes, ma'am?
Are we doing two different ones now?
Yes.
Like this, it's split right there.
Yeah, what? Yeah, it was. Yep. I'm just using the information I had from the previous one in order to fill this one in. Okay, then if we do that, negative 7 times negative 1 is 7. Negative 13 times 1 is negative 13. Minus 11 more. 7 minus 13 is negative 6. Minus 11 more is negative 17. So 11 and negative 17. Then they ask us for the domain and range of f plus g. I don't know if I've ever asked this question before, okay? What we're doing here, I mean, what numbers can I plug in for x? What numbers can I raise to the third power? What numbers can I times by themselves 3 times? Huh? Any number. Can I take 8 times 8 times 8? Sure. Can I take 39.6 times 39.6 times 39.6? Sure, I don't know what it is. Okay. Can I take negative numbers and times by themselves? Sure. You plug in anything. Whoops, that should have been minus right there. Where did I get range from? Jeez, I'm sorry, I messed that up. Domain of f plus g and domain of f minus g. I apologize. I'm sorry. Yeah, they want the domain of when you add them and the domain when you subtract them. So, again, numbers we can cube and square. And what numbers can I plug in for x? Anything. So, help me out here. I think I showed you this symbol before. Double bar r. That just means all real numbers. It's not going to say double bar r. It's going to say all real numbers. I'm just lazy. So, double bar r for both of those. You can plug in whatever you want. Okay?
What is it?
Oh, it's called double bar. It's like a capital R with an extra bar on it. Double bar R. That's a symbol for all real numbers. It's just shorthand. Yeah, that's right. I explained that first semester. You weren't in here at the time, I don't think. Okay, let's try to get 3 more of these. Oh, we got plenty of time. It's not even 7 o'clock yet, apparently.
7.
That's what my clock says. Okay, number 7. Okay, now it's starting to get a little tougher, okay? They're going to get a little bit tougher. F of x equals, and g of x equals, f of x is 2x3, and then cube root of x. 2x3, and cube root of x. Now they're asking you to do this. They want fg of x. Not f plus g, fg. So now what are they asking you to do? Add them or subtract? Times them. Then they're also going to ask you what's f over g of x. We've been adding and subtracting them. Now we're going to multiply and divide them. Okay? So here's what I would suggest you do. I'm going to rewrite the cube root of x. That's the same as x to what power? What little number's sitting right here we don't see? 1. So it's x to the what power? 3 over 1 or 1 over 3? 1 over 3. First is last. Okay, so when we times these, we're going to have 2x3 times x to the 1/3. Now, you're going to a lot of students are going to struggle with this. It has nothing to do with algebra. It has to do with something that students struggle with every year because they hate them, and it's something you learned back in middle school, but you forget about it. Fractions. Okay, it's the fractions that'll trip you up, okay? So, what we're going to do here, remember, we have 2x3 times x to the 1/3. When we times, we do what with our exponents? We add them. We add them, okay? So it's going to be 2, and then we take 3 plus 1/3. Let's do this. 3 plus 1/3, don't think on this. You know what 3 plus 1/3 is?
Another third.
Huh?
2/3.
3 and 1/3. 3 and 1/3. It's like, what's $1.75? $1.75, okay? 3 plus 1/3 is 3 and 1/3. Now, the computer wants you to write it as an improper fraction. You guys remember how to make 3 and 1/3?
Don't you times
You take the bottom number and times by what?
the diagonal.
The big number, and then you, remember you do that 1? Add it. Times this, add that. So 3 and 1/3 is the same as
6.
times. Don't add.
Oh, 9. Times 1 is 9.
No. Times, add.
Oh, add.
Times, add. 10/3. 2x to the 10/3. Okay? Then we're going to have to divide these, f over g. So 2x to the 3rd over x to the 1/3. Okay? Well, when we times, we add. When we divide, we subtract. Okay? We times, we add. When we divide, we subtract. Oh, also, did I tell you guys? No, I didn't. Was this the class? No, it was another class I told this to. Where you guys are going during the afternoon today? I don't know yet. I thought it was going to be, well, initially, I was happy. I'll be honest, I had good news. It was the other classes I shared my good news with because I didn't know at the time. My good news was they're putting like all the freshmen in like certain classes and all the juniors together in certain classes. And this time I was supposed to have sophomores. Sophomores' last names D through F or something like that, which is good because they're not freshmen. I had freshmen during homecoming. That was fun. So, but I think that's when this case was dropped off as my new list. But she said that she had to change it, and I was like, no, don't give me freshmen again. And it's not though. I guess I have juniors. I'm not sure. IOB, is that is there? What does she have there on my? Who do I have?
Oh, you got me?
Oh, shoot.
Gracie, Kyle, Amelia, Alexis.
Looks like 11th graders, I through R. Last name I through R. So 11th graders I through R. That's a pretty good group, except for Iobi.
So,
Okay.
Wow.
So either way, I don't have freshmen. That's always good. Oh, yeah. That's right next door, isn't it? Yeah, this is 7, so that's probably 8.
There's papers, you know when you walk in the, right there, the little lobby? Yeah. Put it in there.
Okay, so we said that when we times, we add, so when we divide, we subtract. Forget about fractions right here. Let's think about pizza. We don't talk about pizza. What's 3 take away a third? What's 3 whole pizzas? Take away a third of a pizza. You ate a third of one pizza. No, you have 3 whole pizzas and you only get rid of 2/3 of one pizza, of just one pizza. So you only got rid of part of one pizza, so how much is left? 2 and what? 2 and 2/3. So it's going to be 2x to the 2 and 2/3 power, okay? You have 3 pizzas, you eat a third of a pizza, not a third of all the pizzas, a third of one pizza. So you have 2 and 2/3 pizzas left. Let's make this into an improper fraction. So what would 2 and 2/3 be as an improper fraction?
3 times 2 is
6,
7,
8/3. 2x to the 8/3. Why are we making improper fractions? Because that's the way they are on the computer. Oh, they are the same. What's raised to the third? That's a good question. What's raised to the third power here? Only the x. Just the x. Now, if it was in parentheses, then yeah, then you wouldn't. Okay, that's a good question. Okay, so then they ask us, what's f of g of, what are we plugging in this time? Oh, I'm going to need calculators. If you got a calculator on your phone or something like that, pull your phones out. Okay, we need negative 27. Both of them? This is still the same problem.
I hate that.
Sorry.
It's okay.
So again,
This is too much work.
well, there's only 10 questions total. It's still less than what we were doing. Okay, so here's what we're going to do. We're going to plug in negative 27. So don't use you can get your phones out now, but we're not going to use it quite yet. So we have 2 times negative 27 to the 10/3 power. We're just plugging in negative 27. And again, where'd negative 27 come from? They told us to plug it in. That's the one they told us to plug in. Okay. So do we times first or do powers first? Powers. What's negative 27 to the 10/3 power?
I don't know.
Very good. I don't either. So what do? Rewrite it. So we have 2 times the what root of what? Third root or the cube root of negative 27 to the 10th power. Now, I don't know what negative 27 to the 10th is. Some people might say, oh, it's 270. It's not 27 times 10. It's 27 times 27 times 27 times, I'm not going to say it 10 times.
You want me to do
Okay?
that?
I know. Your calculator it'll blow up. It'll just explode right there, okay? But you should know the cube root of negative 27 by now. You really should. What's negative? What times itself 3 times gives you negative 27? She would have given it to you. 3, okay? Well, negative 27.
Honestly, I didn't even look
Negative.
at it.
Negative 3. So we have 2 times negative 3 to the 10th. Again, do we times or do powers first?
Powers.
Okay, what's negative 3 to the 10th? Use your calculator on that one. That's not quite as big a number. Somebody want to type that in?
10 times 10 times.
No. 3 to the 10th. Not 10 times 10. That's 10 to the third. It'd be 3 times 3 times 3 times 3 times 3 10. See, I need you guys' help. I can do a lot of calculating in my head. I can't do that. 3 to the 10th power.
You definitely got it. Come
5,
on.
6, 7, 8, 9, 10.
You call yourself an algebra.
177, 147.
Did somebody else get that? 177 what?
147.
177, 47?
147.
147? Somebody else want to type that in? Yes, ma'am.
Isn't it negative?
I'm glad you brought that up. Should I type in 3 to the 10th or negative 3 to the 10th?
3 to 10, because then you can just switch it, right? Well,
It doesn't matter on this one. Because what do you get when you times 10 negatives together? A positive. What happens if it was positive? What happens when you times 10 positives together?
Wait, we're supposed to be doing 10. I don't.
You didn't do it 10 times?
Wait, 3? Okay, I did it right.
They're saying 59,000.
Yeah.
A whole bunch of people saying 59,000. What'd you say, 59,000 what? 59,049? 59,049.
Yeah, that's right.
Are we all done? But not yet, we're still gonna do one more thing, unless you guys did already do it. What have we ignored? The 2. So what do we gotta do with that number on your calculator? Times by 2. When you do that, the computer says it is 118,098.
Yep.
118,098. Okay. All right. Then we're gonna plug it in right here. So it's gonna be 2 times negative 27 to the 8/3. What's negative 27 to the 8/3? I don't know either. So 2 times the cube root of negative 27 to the 8. We've already done the cube root of negative 27. It's what? Careful. Negative 3. So 2 times negative 3 to the 8. Now again, should I type in 3 to the 8th or negative 3 to the 8th? It doesn't matter on this one, because 8 negatives times together is the same as the same 8 positives times together. So 3 to the 8th, whatever that is. So that's 64. Say it again.
Negative 65, 61.
Now I'm glad he said negative. Be careful, it's not negative whatever he said.
All right.
It should be positive. If you're going to type this in, you got to put it in parentheses. Okay? 65, 61 times 2. And what's that? 12, 13, 13, 22?
13, 12,
13, 12, 2? 122. Okay. Okay. Still not done with this one yet. What's the domain? I'm just going to put domain of this one. What numbers? This is a tricky one. You got to watch real careful. This problem's almost done. We've done here in about 30 seconds.
Wait, what did you, the 2165?
That's 2. That's parentheses.
What's this?
Negative 3 to the 8th is 65, 61. Then we still have to times by 2.
Then how we get to 13?
2 times that's that. Okay, what's the domain of this? What numbers can I take the cube root of? Does it have to be positive? Or can I take the cube roots of negatives?
Negative.
So what numbers can I take the cube root of?
All real.
All real numbers. Domain's all real numbers. Now, you gotta be careful here, okay? This is so tricky on this, okay? You might look at this and say, well, again, I can take the cube root of all real numbers. Almost. Almost when you're dividing, okay? There's one thing, you gotta look at this right here. There's one thing you're not allowed to, and listen real careful, I'm gonna say it real slow. There's one number you're not allowed to plug in for x on this problem when you divide it. What? 0. And here's why. Can we take the cube root of 0?
Yeah.
Sure, it's what?
0.
Why?
Because 0 times 0 is 0.
It's 0. 0 times 0 times 0 is 0. We take the cube root of 0. Nothing wrong with that. What's wrong is if I take the cube root of 0, we get 0 where? On the bottom. And what happens when you divide by 0?
Get 0.
What do you get when you divide by 0? You don't get to divide by 0. It's not a number. It's undefined. It's not a number. Okay? If I give you 4 over 0,
4.
that's not a number. It's not a number, okay? And I think I showed this to you before. I'll show it to you again. 10 over 5 is 2. 12 over 3 is 4. Because 5 times 2 is 10. 3 times 4 is 12. 8 over 0. Why isn't it 0?
0
Because
times
0 times 0,
not 8.
0 times what gives you 8? Nothing. That's not a number. That is not a number, okay? You can't have 0 on bottom, okay? So here, the domain for this could be everything.
Except 2.
You can't plug in 0. Okay? Okay, that was, I'm going to have done 3. I'm going to do one more. I was going to do 5. I'm going to do one more with you guys, and then I'll do one for you guys on Monday and have you guys work. Number 9. Okay. All right. Number 9, same type thing. All right. So we have 4x. Okay, you like this one's a little bit nicer. F of x is 4x. And g of x is, what do we have here? 9x to the half. Okay, this is a teensy bit easier because it's already written as a without a radical. Okay, they want us to times them and divide them and then plug in 9. Okay, so f plus g of x. Okay, they're asking us to. No, not f plus g. We're not adding, we're timesing. And if you're sitting there going, how do you know what to do? Well, the add and subtract, it tells you. I wrote it down wrong. Okay, we were adding and subtracting earlier. Now we're multiplying and dividing. Okay, So we're multiplying them, okay? So we're gonna take 4x times 9x to the half, okay? And I'm not making fun here, but every year I have quite a few students that struggle with just the very beginning. The beginning of this problem should be, I think, really easy, okay? This was a tough question, okay? I mean, my answer here, if I simplify 4x times 9x to the half, how should my answer start out? The beginning of this problem, not that you would do it, is really like a 5th or 6th grade question. Well, how's my answer going to start out if it's 4x times 9x to the half? I heard somebody say it, what? Oh, careful, we're timesing. We're timesing. 36, you're saying that. Where'd you get that? Just 4 times 9. Just 4 times 9, 36. Okay, 36. And then x is x to the first. Now when we times, now here's where we got to be careful. Okay, when we times, we add our exponents. Okay, and what's 1 plus a half?
1
1 1/2. Make it into an improper fraction. This times this plus that.
2 times 1 is 2, 2 plus 1 is
36 to the 3 s power. Let's do f divided by g of x. You literally don't need to think on this at all. We're going to have 9 or 4x over 9x to the half. Don't think on this. Literally don't think. What's 4 divided by 9?